Okay, I'll try and think. Okay, all right.
This rocks!
Yeah! Yeah. Who needs .NET Rocks when you got Lewis? There we go. Right. So, hey everyone, thank you for coming. I'm going to be talking about what vulnerabilities today, and I'm going to do some hacking of containers and Kubernetes. So first of all, I'd like to say, please feel free to take any photos. I'm sure you're all aware of the hashtag now. It's the end of Thursday. I hope you've had a lovely day. They have as well. So yeah, please feel free, because I'm going to go through, this is the agenda that I'm going to go through today. I'm just going to give a couple of minutes just talking about why I'm here, why NDC Oslo is important for myself, and why I think you should probably care about security. For me, it took a while in my career until security clicked into my head as why it was so important, and I hope to share that with you today. We're going to have a look at some vulnerabilities. So we're going to look at the most common vulnerabilities that we can use. Spoilers, it's not just about containers at this point, but we'll do that and we'll see how we can access the system. Then we're going to have a look at what's occurring, Welsh pun, within our containers, and how we can then build them securely. So orchestrators, we'll talk about Kubernetes today, and again, that's just containers running containers, but we'll have a look at what we could do at that level to be able to manage our security. And also then we'll just have a general overview as to Kubernetes and other things that we can do outside of our pods to make it secure. And finally, some points about going forward, things that you could take away today, and how you can start putting them in place. And then we'll have a party, which should be quite an enjoyable time. So this is me. I'm Lewis Denham-Parry. I'm now a solutions engineer at a company called JetStack in the UK, and I'm also the co-founder of a meetup called Cloud Native Wales. If you want to get in contact with any of them, that's our Twitter handles there. At that time, that's me and my son, by the way, in Barcelona a couple of weeks ago. So one of the talks I've seen, one of the speakers I really look up to is John Skeet. And at the start of his talks, he usually brings in issues that affect us outside of technology. Mental health is one for me. I've suffered from depression in the past and continue to do so today. And I feel that being able to share that with people, it gives other people help. If you do suffer from any mental health issues, it can be solved, but you need to go and see professionals. But the reason I say that is because in 2017, I came to NDC Oslo, and this was my first conference that I ever attended, the first meetup even. I think I was 32 back then. I was ready to quit my day job. I was completely burned out. I had enough of it. The people that I was working with were not the people that I wanted to be working with. It wasn't against them. It was that everyone was just focused about money. And the thing that helped NDC Oslo help me realize was that I enjoy solving problems. As soon as I figured that out, then that's when I started focusing on my depression, and then I solved that problem. And yeah. Also, it's about community as well for me now. It's that everything's constantly changing. Me talking about security today, you'll find out that this is one thing that I've been terrified about for so long, because I don't see an end game in sight. I'm much more comfortable knowing that I've done something and it's done, and the definition of done, sweet. With security, I always feel that I can't achieve that. So community for me, that's where you've got people around, so it's yourselves, it's people that you can reach out to ask for help and support. And I think that's the most important thing that we got going forward. Last note would just be climate change as well. I've recently found out that 3% of all global emissions are coming from our data centers. So it's probably just time to start thinking about how we're actually managing and running our things. You can get energy grades for the cloud providers that you use. If you're interested in any of this, please drop me a message and I'm pointing you in the right direction. So enough about me at this time. So I'd like to know a bit more about you. So does anyone use containers in this room on day-to-day? Okay, we've got a couple of people using containers. All right, Kubernetes. Cool. In production as well? All right, cool. And mostly on the cloud, or anyone bare metal? Oh, okay. Got some bare metals. Great. Cool. As I said, I'm not a security expert, but I found a way into security. And the inspiration came from a talk that I saw. So that's a link to the YouTube video, and it's presented by Ben Hall of Catacoda fame. Some of you might know him. The other chap was Andrew Martin. On stage, they did live capture the flag. And at this point, it made me realize that actually security could be quite fun. We could actually set up games, and we could learn actively as to how to solve these problems. So on that point, I'd like to thank them both. They're now good friends, but if you want to find anything more about them, that's how you can get hold of them. Anyone know why I'm going to mention Tesla and security right now? Kubernetes as well. Oh, okay. So a while back, they've been running a Kubernetes cluster, and they were a victim to this. Cryptocurrency mining. Yeah, they had a little bit of a mistake there. Now, how did this happen? Was it some amazing tools? Was it someone that hacked into their clusters? Was it anything amazing? It was a Kubernetes dashboard. So has anyone seen the Kubernetes dashboard before? Cool. So this is what the Kubernetes dashboard looks like. So later on with some of the demos, I'll be using kubectl. You can call it kubecontrol or whatever you want, that's fine. But this is essentially what kubectl is, but it's available on a website for people to be able to interact with. This article came back, well, this article was released back in 2018. But first of all, I don't agree with that date format, so it's more like that. But again, we're at a technical conference, I think we could do one better, and we could go to that. So, and it's over a year ago, so nice story, well done. Get your material as close to today as possible. But pop quiz, who in here thinks that this is still an active issue today, that there's Kubernetes dashboards publicly available on the internet? 1, 2, 3, So for video, yeah, I guess majority of the room thinks so. Well, and if you want to have a look, you can go to this link, and you can go right now. So Shodan, our favorite thing, if you search for Kubernetes dashboards, I'll show you some dashboards. So I've done it for you. I've got rid of the IPs just in case, because this one's being filmed. But you can click on the links and you can go into their dashboards. And just to put it into insight, a week ago, that screenshot that I showed of a Kubernetes dashboard, that wasn't mine, it was someone else's in the States. And I took that screenshot. So my first reaction to this was pretty much that face. Now, I wonder what your emotion would be like, and I'm guessing a couple of you would probably be feeling, don't use Kubernetes. So on that point, I'd like to say thank you, enjoy the party, good night, let's not use Kubernetes going forward. But there is a solution as well. I think Kubernetes as a platform, it's getting better. There's some momentum now with the security that we can put in place with it. So it's all about live demos, so let's get started. So our first demo is going to be trying to own a website. So if I swap my screen. Right, I've tried my best to calibrate it out back. On this demo, we're just going to do it locally on a Docker container. It's going to be a narrative of a story going by. All this will be available to yourselves at the end as well, so you can take this back to work and you can show people if you want. So I'm going to split my window. Okay, so I'm just going to run Docker stats there. That should work out okay. Let's see if I still got this here. So I've been updating this throughout the day. So I'm going to run it as privileged, which you should not do. I can't even spell privileged yet. But I'm running it as privileged. That's an anti-pattern. We'll discuss that in a bit. I'm going to be running on port 8080, which is direct into the container port 80. And I'll start running that. So because it's cached locally, it's already started up. Now, without further ado, because the exploit does take a little bit of time, I'm going to run this exploit shell. No, I'm not, because it's not in the right directory. Cool. So that exploit has started now, and it's trying to get a backdoor into the website. As it's running locally, I can get it up onto this website here. So NDC Oslo, I've made you a contact form if you like it. I saw some talks about CSS grids yesterday, so I think I could potentially update this to make it look a little bit better. But that's what we're trying to attack right now. So behind the scenes, I've got a script running locally on this machine that's trying to get into that. Now, that site's in PHP. I don't know PHP. All I know is this exploit. And I found this exploit because they become publicly available. So I was searching GitHub and, well, searching Google. I was just searching around for some decent exploits. So this is CVE, which is a common vulnerabilities and exposure program. They catalog software and firmware vulnerabilities. So once fixes are put in place, occasionally, then they get made public. And so that's when you can start using them for yourselves. So I've chosen this one. Again, I'll share the slide it's all in a Git repo, so you can have all the code yourself as well. So you're more than welcome to use this one, but equally, you might find others that you enjoy yourself. And at this point, I'll go into slides as to why I'm starting with this, but these are the most common exploits as to how you get started into taking over someone's cluster. Maybe I should have picked one that was a little bit faster than this, but whilst that's happening, let's just tidy up the screen a little bit to make it easier to watch. Or is this demo guards? I hope it's not demo guards, because I got 5 different demos, ending up in the cloud with DigitalOcean, which gave me the biggest fright of my life at about 10 a.m. this morning. So yeah, okay. I think something's about to happen. So what we're trying to do here is that we're trying to set up a shell. So what we're trying to do is we're doing an injection attack so that we can send commands onto the hosting system that has this website. So this vulnerability was something within PHP that was back in 2016. We'll look at ways that we can manage it. Oh, there we go. So we got a remote shell now. So I'm just going to clear the screen. So we can just send simple commands. So I can just list, so I can see that there's a folder there called vulnerable. I'm currently in the working directory of www. What else? I could probably see some processes, which, yeah, who am I? I can do that now if you want. Who am I? There we go. So we can start getting some information about this. And so we've got in, this isn't ideal at the moment, but we'll build on it. But before we build onto it, oh, that is my slides. Sorry, there we go. I did some filming just in case none of it worked. But let's review. So as I just said then, we did an injection attack, and now we're onto a box. We don't know where we are. At the moment, it's currently on this machine. And that vulnerability was nothing to do with me. That was just a package. That's just something that I've hosted on a website. So has anyone in here knowingly created a vulnerability? Like, hands up if you have. OK, we've got a couple of hands, a couple of honest people. Cool. Because I think it's this thing. It's like if you make vulnerable things, it's because you're on a learning curve. You just think, actually, this is great. We could do our query that could just be a parameter within our website. That sounds like a great idea until someone shows you that it's not a great idea. But it's the thing. We shouldn't deter people for trying. We should help them. We should help people progress. We should help this learning curve. So I found this from OWASP. And so instead of giving you URLs, just search Google for it, and then you can just find some of the attacks there. And I'm sure other people have spoken about it so far this, and we're going to focus more on containers now. But that's what we did. We just injected a script. So what is a vulnerability? It's a flaw in a code that an attacker can exploit with undesirable consequences. There was a popular one a while back called HEARTBLEED. Was anyone affected in this room by HEARTBLEED knowingly? No, not knowingly. OK, cool. So there we go. Just check when you get home, just in case. So it's a vulnerability in a popular library called OpenSSL, and it allows anyone on the internet to read the memory on the systems protected by the vulnerable versions. So it's comprised of secret keys and allowed attackers to eavesdrop on communications. So it wasn't that great. But to that, I'm just going to now do a jump into the box. So we'll go back to the demo. So, right. So like I said, when we got into the box, it was kind of cool. We could start sending some commands across, but it wasn't great. Let me just see if I can switch those two there. Cool. So what I've done is I've created something called a jump box. I've forgotten the other term for it. If anyone wants to try it out, that's great. But what this is it's just a VM in the cloud. And the difference between that VM and this machine is that it's got a public IP address, which means that I can ping that IP address from anywhere, from the container running inside my machine. So if you want to look more into this, again, the code's going to be available. I'm using ncat listen, and so it's listening out now. And then I'm going to run this command now on the remote shell. Does anyone love Bash in this room? Yeah, got some Bash fans, right? If it's just the most amazing language, I love it. There's a great book called Learn Bash the Hard Way by Ian Mehill. I'll tweet it afterwards. But if you commute a lot and you don't have good internet signal, it's a great book for just learning how to do great things in Bash. So just running that one Bash line, now you can see that my remote shell is changed. So I can see that I'm somewhere else. So again, let's do a who am I. So again, a bit more data compared to the first time. So I can see the processes. This is looking a little bit sweeter. But let's have a look at this. Let's see what we... Oh, no, I'm typing it all wrong. There we go. So I can now see the processes running within this container. At this point, I'll probably close this shell up here just to try and make some more room. Right. So now we're in there, what can we do? Let's just try and be malicious, and we'll just try and change the website. So we don't have Vim available, so we can't edit it. I'm just going to try and edit the HTML of a PHP code. So I don't have Nano, so what I could just do is I could just echo just to see if I've got write privileges, and I could write hi, and I could just pipe that into index.php. So if I go to the website on here now, so now we can see, again, I'll add some more styling on that over the weekend. But now I've been able to update the website, and that's great, but that doesn't really give me anything. I want to go a bit deeper into this. So let's go back to the shell for a sec. So we need to be able to download things. Now, I'm going to pretend I don't have access to curl at the moment within here. But what I could do is I can start looking around. And just by doing Python version, I can see Python's running there. And again, just by searching Google, I found some nice little tools. So I found this function called get. So if I run get, now using that function, I can bypass using curl, and I can start downloading things. So I'm now downloading. I'm on my jump box, up in the cloud somewhere, reversed shell back onto my Mac, into a container, and I've just downloaded something. And I've downloaded something called, I didn't do that right there. So I've got, there, am I contained? Now, we'll touch on that in a moment. But now what I'm able to do is I'm starting to be able to download and install my own things onto this box. But at this point, we'll go back to a little bit of discussion in a demo. Cool. Skip the video. There we go. So how can we prevent this? Now, this is now in a container. Now, let's start focusing about containers. Let's start learning from there. Image scanning. This multiple different things that can happen within an image scan. So you might already have some of this in place. So you've got packages and files that we can start scanning. This is your own code, and these are the dependencies that you have. So if it's a website, it's for packages that you're downloading from NPM. If it's a service, it might be a NuGet, or if it's a monolith, it's pretty much everything you can find on the internet to try and get it working. All of these could have their own vulnerabilities in there. So you could use an image scanner to try and check some of these. The other thing that we can have is scanning for static tokens and passwords. So has anyone checked in a password into a repo before? Yeah, cool. Did you get an alert straight away? No. OK, I'll try and get it set up so you get an alert straight away, because it's kind of embarrassing when it doesn't. Yeah. But again, it's just, what we need to focus on is this improving learning curve. So as soon as you do something wrong, you're told about it, you fix it, and then you get to learn. The other thing that we can scan are third-party images. So with containers, they're based on different images. So we can pull an image from a verified source. So say we're running a website, we might pull it from Nginx. Now, should we trust that that image from Nginx is secure? No. Don't trust any image on the internet. Even if it's verified, even if it's from a big company, you don't know what's happening there. So we need to always scan to find if there's any bad images. Now, these are the tools that you can use to do this. So you've got Clear from CoreOS, and there's Microscanner from Aqua Security. So again, it might be a bit difficult, but the YAML will be available afterwards. No, this is a Dockerfile. But all we're doing in this is that we're running Microscanner during the Docker build process, and then that's going to start verifying our image at that point. Can you trust that? Good question. I'll buy you a beer. That was good points. Yeah. And Norway beers. Oh, God, I'm going to be bankrupt. So another tip on this is schedule builds. Now, I'm going to start just talking about CI/CD. I think CI/CD is the most important thing right now. When we check in code, we can start, all these processes start happening. We don't want it happening locally on your machine. We want it happening somewhere else. We no longer want rockstar developers, even if Dylan BT gives you stickers. We want to have people who are we just want people to check in code and then get the feedback loop. Saying that, though, with a microservice setup, then we might have something such as send emails. And it's not that exciting a service that we might leave alone for over a year. But then over that year, then we can find vulnerabilities that are within that. So if you set up a job, say, for every 24 hours, just to be able to start a build within these, then you'll be actively checking as well. So like I said, focus on CI/CD. Fail as fast as you can as well. So fail if it's not secure. It does sound harsh, but then if you're going to fail it, then people can learn straight away why it's happened. And this is great for when you're onboarding new people. Now, there's an anti-pattern as well, so In Docker and Kubernetes, we usually exec, but we'll say don't SSH to patch for now. Any fixes that you want to do within your build process. If you have to go into these images or whatever, and you have to update things and install things, this is causing drift. And this isn't repeatable as easily as if it's within a CI/CD. Reduce your attack vector, trying to have as little code as possible. Don't just fill it up with code and try to look amazing because you've got lots of lines of code. Also, if you can get to the extent, some people just have binaries running. So if you run Go, then you can just have a binary, so that if you go, you can't really exec into the container. There are ways that you can bypass it, which I can show you if you would be interested. But focus on that. And saying that, does anyone do multi-stage builds in here? Is anyone aware? Cool. Sweet. So multi-stage builds, the process is that you use the tools to be able to develop your software or create the packages at the first step, then you just copy the output into the next step. The thing is that when I've been going into these containers so far and using these tools, if these tools are available, people can use them maliciously. And it doesn't even have to be a foreign actor. This could just be a disgruntled employee within your business. Private container registries. So public is great, open source is awesome, but when you've got a business to run, you want to know that you want to know who's got access to it. So you want to give tokens to people and permissions to for people to write. I say people again, you want it to be a CI/CD. You only want your CI/CD to be able to write to the repository. Then you want to use just GET requests, and so then you can only verify people who take it back. So how do we define these images? So this is probably the worst place that you can start is by doing latest. Now the issue with having latest is that looking at this, you can't tell what's actually running. This is a bit better because then we can start using versioning, but again, we can overwrite these quite easily. So it's give and take, it's your decision, it's sweet, and then you could just automatically, so when a patch is released, it automatically gets installed the next time it runs. This one's probably a bit overkill, but you can use the SHA key, because then if you use that, then you know for a fact that that is the container that's being run. When that changes, then you have to change that key. Saying this, within production, you always want to pull latest. It's great to have local cached images when you're on the train or when you're on a mobile hotspot, but when you're in production, pull latest. And the image trust and supply chain. So again, this is an issue of trust. So for this, I'm going to walk away from technology for a second and talk about the TYLENOL cyanide deaths. Happy topic. In the 80s in America, TYLENOL was one of the painkillers that you could purchase at a shop. Now, it was produced in a factory, it was distributed to shops, and then it was purchased. Now, in between the factory and the shops, someone laced these pills with cyanide. So people went to buy pain relief, took the pills, and then there were 7 fatalities. But there were more fatalities from copycat killers. The way that we solved this quite quickly was by just adding a plastic seal to the container. And so you know that as soon as they left the factory, that it'd be safe to use if a plastic peel hadn't been opened. So we can also do that today with our tools, with our Docker images. So we can use things such as the Tough Project, who offer Notary, and there's Graphias as well. These have digital signatures to verify that the images that you're running are actually what has been produced. So on this point now, we're going to try and escape the container. So let me swap my shell. Cool. So we got to the point of am I contained? Actually, at this point, I'm just going to quickly jump out of this. Instead of using a remote box, just because I'm concerned about the internet connection, and I'll close this, and I'll just try and make it a little bit bigger for everyone. Cool. So we're going to run the same container again. And then let's spin this one up. And we're going to exec into this again. So this is putting us back in that position. Oh, if I knew what it was. This is putting us back in that position when we were on our jump box. So docker exec IT for interactive terminal, and then you can just reference it by the first couple of characters, and then specify bash is what I want to be running. Right, I'm just going to stick that function again, and we're going to now pull down am I contained. Now, this is from Jessie Frizzell, who's the queen of containers. She's amazing. She's phenomenal. Yeah. So I've got a slide with her Twitter handle. If you don't know who she is, I'd recommend following her. So now we've got am I contained. I'm now just going to move it into a directory. Now I'm just going to check that it's all confirmed. So just run the next key. So the purpose of this is, now that I should be able to execute it. I don't know if that's a trailing line here. I'll run that again, but I'll clear the screen so it's a little bit clearer. So Am I Contained? It's a tool that we can use to be able to run when we're in an environment to find out if we're within a container or not. So with this report, we can see that the container runtime is Docker, and it starts giving us some information. And some of the good information I can provide is also the capabilities to what we're able to do, which are all here. There's some interesting ones that, like we've got sysadmin and stuff like that. So within this container, it looks like it's actually quite a good place to be starting. Right, let me exit that one actually. Clear the screen again. Got to exec into that. So we saw that we got some nice privileges because whoever wrote this file earlier on didn't know what they were doing. So let's have a look at what we can do. So I can list some stuff now. Some of these folders look a little bit interesting, but let's have a look at what we've got here. And actually, let's bring it to the top of the screen so we can all see, because that's quite interesting. So we got this here, which is a host. So we could potentially use that to mount into, and then we could take control of a host, which would be kind of nice. So if we want to do that, let's make a quick directory of temp and then host. And so if I list what's in here at the moment, there shouldn't be anything. But now if I try to mount the dev and SD81, and okay, have I typed? Oh. Yeah, that's one. Thank you. And so now if I run list again, now I can start to see some things, and there's some interesting things that I can see. So let's run list again. So I can see that we've got some, well, we've got stuff like containerd, Docker, but kubeadmin, and kubelet. Kubelet's quite of an interesting one. That's kubelet is a binary that runs on our nodes within Kubernetes to find out if we got any work to be able to process. So let's deep dive into that for a sec, and let's see what we've got. Sorry. So we've got PKI, and now we've got a kubelet cert and a kubelet key, which might be quite nice. So let's just have a look. Anyway, I'll show you in a sec, but we'll come to that next point. But the thing is, what we've done is that we've managed to escape our container, and now we've actually got some of the keys that are available, and those tokens are kind of important because it authenticates back to the Kubernetes API, which we'll have a look into now. So running on containers on Kubernetes. How do we learn? How do we learn how to do this? How do we learn how to manage it with security? So I took this screenshot, and again, sorry, apologies in the back, but it was searching on Google for different levels, different types of security. So AWS security has just under 2 billion results. Google Cloud security is just under 1 billion, and Azure security is 850 million. So then I changed this to being specific about Kubernetes, and there's just under 19 million for Kubernetes. But the point with this is it's just turned 5 years old. It's still relatively new. So what could possibly go wrong? If it's relatively new, what are the things we need to be aware of it? Well, we could have exfiltration of sensitive data. So people could come in, take the data. I received a text message from a bank in the UK yesterday, which was weird because I don't bank with them. And they sent me a link to say if I click here, then I'll be able to transfer some of my money. It was just a HTTP link with an IP address. So someone's got my data from somewhere. I don't know where, but that's kind of frustrating. Elevate privileges inside Kubernetes to access all workloads. So we're running not just one pod. If you're running just a single container, in Kubernetes, like, bravo, but I think you're wasting your money there. But what we could do is that we could find a weak point, and then we could go from that weak point, and then we could go through and assess what's happening within that cluster. We could potentially gain root access to the Kubernetes worker nodes. Like I said, that's kind of similar to what we did just there with Docker. But if we do that, then we can control a binary. Kubelet is just communicating with Docker that's installed on the worker nodes. So could we potentially look at what's running on there? We could perform lateral network movement outside the cluster as well. So once we're in, we can start getting out. And we've also got the potential of running a compromised pod. So it looks silly, but it's people. Even though if you give people access to kubectl, then you can just reference files off the web. They could just be from anywhere. You could just have an email being sent across saying, "This is a new technology to use. Why don't you run it on your cluster now?" And then you could run some things such as this. So does anyone know what this is? So this is a fork bomb. Again, beautiful bash. It's 13 characters. What this would do if you run it is it just spins up, it just divides by 2, hence the fork bomb, and it takes all the processes out of your cluster, all your process out of the cluster. Now, that sounds great, but it's like, what's the problem with that? Well, it's because if you've got other things running around your cluster, and this is taking all your workload, and it's just a bash line, then it's not really going to be working that well. You'd probably end up just trying to scale your cluster if you didn't know what was going on. So Kubernetes is secure by default, yeah? So Kubernetes is feature-driven. Security is a hindsight. It gets to market as quickly as it can, and then we find the vulnerabilities. And the prime example of this would be Helm. Helm is a great tool because it can take YAML, and then you can switch values within it for different environments. So you can have the same YAML for your development environment, your QA, and anything else. But the problem is that you use something called Vatilla, which has so many, I think it's pretty much admin access to your cluster. So as a weak point, if I was trying to attack your cluster, I look to access Vatilla, and then I've got complete control of it. So security does follow, though, and so Helm 3 addresses this. But let's talk about some best practices. So least privilege. When you're creating things, just give it as little privilege as possible. It's easier with microservices because you should only have a couple of things, if not just one process that it's focusing on, but ensure that it doesn't have access to the full range of full suite of network availability and such like that. Reduce host mounts. So when you mount onto the host, that's going to be an next point we're going to do next. You can access the machine, and when you do that, you can mimic what's actually using that, and then we can look at escaping and elevating our privileges that way. And limit communications. So when you spin up a cluster, it creates its own network on the inside. If we don't manage that, then anything can communicate with each other. This is an ideal, and again, if you get inside, then you can do what you want. However, that slide didn't work out too well. Don't use root. There's a couple of times when you would want to use root. So if you're running on privileged ports, so if you're running on port 80, which you don't need to do because you can use services within Kubernetes that mitigates that. Installing things onto the container, which you don't really need to do because you should be doing that within CI/CD. The main one here would be that the reason to use root would be to be running on the nodes of the kernel. So how do we avoid this? Well, it's just within our Docker files again. We can specify the user when we build our Docker file that we want to be running as. At this point, I want to talk about RBAC as well, because if you start with Kubernetes, then RBAC is definitely what you need to be focusing on to get the most win and most gains. So RBAC started from 1.8, and previous to that, it was ABAC. Previous to that, they had no security. So you've got role assignment. So this is, have you got permission only if a subject has been selected or assigned to a role. And then you've got role authorization. So a subject's active role must be authorized for the subject. And then you've got permission authorization. So with these, then we can control what roles within it, what users have access to what's running within our cluster. So I've alluded to master and worker nodes. So the master is the brain of the operation. Within the master, we have something called the control plane. The control plane is accessed via an API. It's just any standard API which has its vulnerabilities. So we can look to manage that, but again, that's kind of a drawbridge. We need to have more security in depth. The workers are your other nodes that are processing the workloads. So to help mitigate this, a layered security approach is the best way, so it's defense in depth. So we'll just go through quickly some of the things that we can have. Again, these slides will be available if you can't make that out. But admission controllers, so when workloads come across, and after authentication and authorization, the admission controller determines if it can be processed or committed into etcd. So etcd is a database that is used within the control plane to manage Kubernetes. It's declarative as a key value pair. at this point, once it goes in, that's when the process starts to be able to assign workloads. So from this, we can specify that we need an always pull images policy. Again, this is just to make sure that we don't use cached images, so that we don't avoid registry checks. We can deny escalating exec, so this means that when we've seen me in the container so far, we've been trying to escalate our privileges. This helps prevent that from happening. We've got pod security policies. Now, these are just YAML, but they're very powerful, and so it kind of looks like this. You're not going to be able to see it, but some of the picks are to say if you're privileged. So if a pod was trying to be run as privileged, it would not be allowed to run because it can't be, because it's privilege false. This allow privilege escalation is false. So that's, again, security in depth. That's just to make sure that it happens. We've got run as user, so we require a container to run without root privileges. And we've got supplemental groups to forbid the adding of a root group. We can also limit range and resource quota. This helps prevent against DDoS attacks, for instance. So there's a table there of everything that we can manage in resource quota, including CPU, memory, pods, services. We can also have node restrictions in place, so we can define what can and can't run on these nodes. So now let's go on to the next demo and see what's running. So at this point now, we're going to go up onto into the cloud. So again, I really hope no one's been able to find this cluster for the last couple of hours. Yeah, it's been one of those days. OK, cool, that's sweet. All right, I think we're good. So before I do that, save that. We're just going to jump into this container again. It's still running. Can't spell Docker, PS, Docker exec, and then we can still. So within our file system, we can go to var and we can go to run. So I'll clear the screen. This is back in the container, so this is back on my machine. So this is just running as a Docker container locally on my machine. We're using Docker for Mac. So when I look within var run, I can just see a couple of folders there, nothing too exciting. But now if I exit this, and then if I use kubectl get pods, so I can see, I'm going to start with bash and curl. So I can do kubectl exec interactive bash and curl. I'm going to run bash. So now I'm in a pod somewhere up in the cloud. So because it's running with Kubernetes, Kubernetes likes to add some things into this pod. So let's have a look if we can find it. So if I change to var run. So now it's the same. I'm running a container, but I can see that there's some things in there. Now, if I was looking for something, secrets is kind of a giveaway as to somewhere where I want to start. So let's go into secrets, and so then it's Kubernetes. So that's probably something that's going to have interesting. Service account, that sounds even better. So let's get into the service account. Oh. Have I lost connection? Oh, it's going so well. Yeah, that's dropped. No, I don't. There we go. There we go. I'm back in. So there we go. Sorry, let's var run Kubernetes secrets. Kubernetes service account. Now, again, I've got a cert in here and a token. So a token sounds like something I would like to take. So I've got that there. So let's export that now into token. Token equals cat token. And then I can echo that token just to make sure that we got it. Cool, we got that. So why am I doing this? Well, it's because I wanted to show you something else. Let's just go over there to try and save some space on the screen. I didn't want to come all the way out. So now, because I'm within the cluster, it's in its own network. So it's got its own DNS, so I can start looking for some things. So if I, for example, I can just go to Kubernetes, and then I get an authorized request. That's me hitting that API that I've been talking about on the master. Now, it's unauthorized, but I've got a token. So let's see if I can use that. So there we go. I'm going to do a curl request, but this time with a header of authorize a token. Nope, but I'm still getting authorized failure, which isn't great. Yep. Part of this is supposed to happen. Oh no, I don't even have a token. I was expecting a different error, so let me just quickly grab this one. There we go. Got my token back. There we go. So just because I added that token to that request, I'm now able to see all the pods that are running on the default namespace. So let's have a look. Instead of that, let's bang bang it, and then we'll grep, and we'll look for bash. So because that's what this container is. So I can see some things saying bash here now. Let's look for anything interesting. So I can see the security context for this is privileged and set to true. So that's probably something I'd want to take advantage of if I was outside of this container looking at something else. So I can see the container ports, and I get more information. Leaking this kind of information just gives an attack surface. It gives more knowledge to the person who's trying to take over your system. So let's clear that. Now, the way we can mitigate that is with RBAC. So let's see, kubectl delete hyphen file. Let's see. Oh, wrong directory. So now that I've deleted that, I've got the RBAC permissions back in place. So if I go to do a curl request again, nothing should come back, because I shouldn't grab that. So I'm getting a forbidden request now because RBAC is back in place. It's now doing the authentication. It's saying that the default account isn't allowed to talk to the API, which is a very good thing. But again, just for us to start being able to do some demos, let's put that back in place for the final one. I think I need it for the final one. So I've put that insecurity back in place. Cool. So we'll go back to some more notes. So we got security boundaries, so the structure of Kubernetes. So we talk about clusters. Clusters is comprising of everything that we have, so nodes in the control plane. You might have multiple clusters set up for different environments, or you might try to spin up environments within your cluster. So within our clusters, I've alluded to, we have nodes. So nodes are your virtual machines or your bare metal. They only process what is scheduled, and they use something called the kubelet to be able to find out if there's any work that it needs to carry out. We have namespaces, which is essentially a virtual cluster of multiple resources. It's a basic unit for authorization, and it can restrict resource depletion and prevent denial of service attacks. So then we have pods. Pods are a group of containers that can run on the same node. So yes, you can have one or many containers running within a pod. Network policies, we can use these to restrict what can and can't talk to each other. We can also restrict what's going out of a network as well as what's coming in, which would have restricted me from being able to get out onto that box. Secrets. Anyone using secrets in their Kubernetes cluster? And are they encoded or encrypted? Well, yeah, it's all just base 64 encoded. So even though it says it's a secret, anyone can decode whatever secret you have. Back to that Tesla incident on the Kubernetes dashboard, you're able to get access to their S3 tokens, and so they're able to exfiltrate the data from their S3 buckets just by looking on a website. To solve this, you need to look at third-party providers. So you've got people like HashiCorp who have Vault, which can be incorporated with it, and then you've also got sealed secrets. Sealed secrets are when you can write a secret locally on your machine, but they can only be decrypted on your cluster. Passing secrets to containers, the way that the best practice for this is that they are passed as either environment variables or you mount them within the container. So we've got a couple of tools that we can use for this as well. So we've got Aqua Security. Aqua have KubeHunter and KubeBench, both are open source. KubeHunter is a penetration testing tool. So you just run it as a job within your cluster, and then it gives you a detailed response, and it tells you any known threats that you have within your cluster. That's a really good way to get started. KubeBench is based on the CIS benchmark. And again, you run this within your pod, and you run this as a pod within your cluster, and it gives you a detailed report as to what's vulnerable, from critical just to a warning level. So I'm going to go on the final demo now, and it's called the Hail Mary, because I'm going to hope that we get all the way through it. Yeah, going all in. So all of these steps, by the way, initially, I was doing this with someone else, and we are going to do capture the flag between ourselves. But as it's just myself, it's going to be very difficult for me to capture my own flag. All this will go together so that it can show you that from the start of that exploit all the way to the end, that you can then own a node, which we're, spoiler alert, we're going to try and own this node. So saying that, I need to have that connection working, and I need to swap the screens. Thank you for mentioning. So there we go. I don't think I need this one running up there anymore. I need to be out of this. Cool. And let's get rid of that. OK, so kubectl get pods. I spun up this pod earlier on because running this exploit, what I want to do is I want to run Docker within Docker. Now, to run Docker within Docker, I need to install the client. And I was having some issues with speeds, so for brevity, I've already installed it. So if I exec into Docker exploit, cool. So we can't find a security group, but we should be able to get around that. So now I've run the other tools, so hopefully we can do that. So that doesn't look too good, that warning. Nope. OK, let's see if we can just get this bit done. So what I'm doing here is that I'm just trying to, because I've got privileges within this container that we got access to. OK, we're going to go back up here. I'm trying to install Docker, because if I can install Docker onto it, then that means theoretically that if I can get access to the Docker socket, then I can read what's happening on the node. Now, last chance, otherwise I'll swap. Yeah. I'll swap to the video. Yeah. And the video doesn't start. Great. Thank you. I've done something wrong in the past life. Cool. OK, we'll give us a quick go. Let's just hope for the best. So what I'm doing is that I'm in this container. I'm trying to install. Oh, yeah. Thank you. All right, we're going to exit this. We're going to go straight back to root 1, kubectl delete deployment. End of days. Right, kubectl delete deployment. There we go. So I'm deleting the deployment so we can start fresh. So it's going to spin up a new pod for me now, hopefully called deployment. So now if I do kubectl get pods, and I'm going to watch this pod, and then I'm just going to wait until, so I can see the old pod is terminating, and I've got a new one creating. The -w is a flag called watch. So now we can see that it's running. So let's do kubectl exec -it docker exploit f bash. So again, I'm just trying to get to the state that we finished off in the last scenario. So we've got in here. Now we're going to try and install Docker in here. So this is the next bit that. Yeah, yes, again. See, it was that last minute thing of me thinking, you know what, I'll just get it prepped so I can spare time. So yeah, so I'm installing Docker into that. Now, within this image, I've left the Docker socket to be a vulnerability. Now, I'm going to try and exploit that. So I can jump on top and get into the node. If I get into the node, because kubelet determines to that node what it's running within Docker. Now, that's quite cool, because if I can control Docker, then I can see everything that's running on the node. So that's the position I want to get to. Because if I can see what's running on the node, then essentially I can start running what I want on the node. OK, we're almost there. OK, that looks a little bit better. Let's clear the screen. Now let's try Docker version. There. God, thank God that speed was a lot faster than the hotel. So I've only installed the Docker client, and because I've mounted the socket, it's found a server. So I haven't installed a server within this. I've just installed the client. So first of all, let's just try a simple one of run docker hello world. So I've been able to spin up a container there on that. So as well as that, then what I could do is if I clear the screen, I can do a docker ps. Now, that's all the Docker containers that are currently running on this node. If you have a look at them, you can see that a lot of them are Google ones with K8s for Kubernetes running. Can I see if I can exec into that one? No. Sorry, Docker exec. Getting lost as to where I am. No such container. Well, let's just try and find another one. It's just there, that one should do it. Docker exec, interactive, bash. Oh, I can't spell bash now. There we go. So now I've changed it, and now, so Kubernetes has been spinning up these pods. Yeah, bash and kill was the one that we used in the scenario 4. So now I'm able to mitigate that and go into that and exec into that. So this is when I could start just sniffing around and I could start installing things in there, watching the network traffic, see what's happening there. At that point as well, then it's a case of, well, if we can start doing that, then maybe we could start running our own containers. So if I come out of that, so now I'm back into our exploited container. Let's see if I can, let's just do a quick who am I, and then we'll do uname. And then we've got, so looking at this, yeah, I can see that it's Docker exploit, so I think I'm still within a container at the moment. And then if I just check the operating system, so yeah, it looks like I'm using the Ubuntu image on this one at the moment. So I'm going to run this container, and now this container is going to do attached to the PID of host, so process ID of host. So now I've just got a new shell, which looks exciting. So if I do who am I, I'm root again, but if I do a uname, I'm on a Linux node now. So now I'm on the worker node. I'm just on the machine. Let's just check, because I was previously on Ubuntu, so now I'm running on Debian. So I'm quietly confident I'm actually on the node that's running it. So if that's the case, then let's change to root and .ssh. Let's just cat authorized keys. So that's my public key. That I put on DigitalOcean. Yeah, it's cool. I'll line up the next one. I've been very careful so far. Like, when I get a bill after tonight, it's could be interesting. But the fun thing about that is that now I can just do what we did earlier on with a website. So I just echoed onto it, which means that I could just start adding my own public keys to this. And we can see Oslo's there in the bottom now. So I could have added another key so I could SSH onto that node. So we started off on the website, we got into the container, we got out of the container, then we got out of Kubernetes, and now we're onto the node. Cool. So I'll just wrap up on there. So going forward, runtimes, it isn't just about Docker. There's other runtimes available. Docker shares a kernel, that's why it's super fast. That's why it's faster than VMs. But then when we have kernel panics, then that can be potential issues. The solution to that are new runtimes. So there's Kata containers and gvisor by Google. What these are essentially is, quick overview, they're just VMs within containers. But then that mitigates that security issue. Service meshes, almost, there we go. They can offer mutual authenticated TLS connections within your network. You can also set up service mesh network policies, and so you're looking at Istio and Linkerd for these things. So release often and release fast. I've worked in business previously where I started a contract there, and before I left after 3 months, my code hadn't even reached production because of the process chain that they had. If that's an issue. You need to start firefighting these things. If you're comfortable with releasing daily and consistently, then it doesn't become an issue when you have to release a quick patch for a security issue. kubesec.io. So if you are writing YAML, if you go to this website, you can submit your YAML onto the page, and then it'll give you a score. It'll tell you what's missing in there, and it'll tell you what you're doing great. You can also use this as a service within your CI/CD. So then your YAML can be scored when you're submitting it in. Look at approaches like GitOps. So GitOps is about having your infrastructure as code, and you've got a source of truth, so that instead of using kubectl like I've been doing today, you just be checking in changes to your infrastructure within a Git repo, and then you've got a worker on your cluster that manages that for you. Chaos engineering is fun. And the great thing is that if we're used to deleting pods and wiping out nodes throughout the day, then if we need to do a security patch on a server, then we can take it offline knowing that we're already sorted that. And it's the same for pods. We can just say at the middle of the day that we can take pods offline. And always just patch, just security updates, just as soon as you see them, get them, because I hope that I've inspired you to start having a look at some of the issues that we have with security, and I hope that you can take it back to your colleagues and then just try and show them something and say, I'm in here, try and get me out. So thank yous. Again, I'm standing on the shoulders of giants because I don't know much about security, but I've learned from a lot of people. So there's Andrew Martin again, Ben Hall, Benji Portney, he's helped me out with slides. Liz Rice is amazing. And as well as that, so there's Jessie Frizzell there, Ian Coldwater, so if you want to know more about security in containers, she's great. And then Alid and Niall as well. Over the last 2 years, the most important thing I've learned is to drop the ladder. So everything that I ever do, I make sure it's all publicly available. If you do want to use any of this material, please feel free to present or use or change it however you want. All these Thank you. I know, it's a great thing. But yeah, without further ado then, I guess I'll pivot back on, but enjoy your party tonight, and I hope you enjoy the rest of your NDC. Thank you.